Welcome back to another video. Why did the toilet paper roll down the hill? To get to the bottom. Okay. Boom. Let's go to today's topic. Strap yourselves in. It's a lot of content. Okay, so today we're talking about the quadrants, signs. Okay, the quadrants essentially is going to be quadrant 1, 2, 3, and 4. I'll explain that. Your sign is got to do with plus and minus. And then the related acute angle just basically means anything that's in the first quadrant. So before we can get to any of that, it's very helpful if we understand what sine, cosine, and tan look like as functions. Okay. Now you can make an exercise out of this and you can say, okay, put in your calculator sine 0, sine 90, sine 80, sine 270, sine 360. But for the time being, I know that it's going to end up looking like this. And I'm going to draw it to the best of my ability. That's what sine is going to look like. Okay, you can test it with your calculator. It holds up, it works. Okay, now just a couple of things to note here. I'm not going to do it for all of them, but we know sine 0, you can see here that that's going to be 0. Sine 90, I can see that's going to be 1. Sine 180, we're back to 0. Sine 270, we're down at -1. And sine 360, we're back at 0. It just kind of shows you a little bit of what's going on. Okay. Now we've got cosine. It looks very similar. The only difference is it's going to look a little bit like this. Okay, so we go down, peak at 180, go back up and end up right back at 360. And here you can do the same thing with cosine. I won't do it for time's sake, but I'm sure you can write those things out. And for tan x, now tan x is always going to be the random one. So there's always something going on with tan. Tan looks a little bit like this. Okay, we have these two asymptotes at 90 and 270. And then it looks a little bit like this. Okay, now the reason that we go up to 360 when we're talking about 8 degrees is because generally there's 360 degrees in a full rotation. Okay, so that's where this comes from. And then at that point, it repeats on either way. So that means it would repeat on this way, it will repeat this way, and will continue on here if I was to continue on the graph. Okay, but for now, just to make things a little neater, I won't worry about that. Now that we understand a little bit about what they look like as graphs, it makes a lot more sense when we start talking about what we call these quadrants and these all stations to central. Okay, the first thing that I would note is usually we would start at 0 degrees up top. Now what we're going to do is we're actually going to start it here because this becomes our first quadrant here. First quadrant, this becomes your second quadrant, this becomes your third quadrant, and this becomes your fourth quadrant. Okay, and so that's 0. Now as we travel this way, that goes to 90. As we continue on, this becomes 180, 270, and then this becomes 360. Okay. Now, what you'll start hearing a lot of, and you'll remember very, very quickly, is all stations to central. Okay, so that's what that is, all stations to central. So I have all stations to central. Okay, and so if you remember this diagram here, this is going to help you with majority of your trig equation questions. Okay, now you'll also have this ASTC. Now, what does it all mean? Other than all stations to central, I want you to think of it as it tells you what's positive. So for A, it'll tell you that all is positive. Okay, for S, we'll say that only sine is positive. For tan, for T is going to be tangent, or I'll just write tan is positive. And then for C, only cosine is positive. Now, what does this all mean? All stations to central. It will make sense, hopefully, at this point now. If I was to show you this whole graph, hopefully everything fits. And I know it's going to be a slightly smaller screen, but if I look between 0 and 90, that's my first quadrant. So in other words, between 0 and 90, 0 and 90, 0 and 90. What do I notice about all my graphs? Are they above or below the x-axis? Well, that's above, that's above, that's above. All of them in the first quadrant are positive. Now, what happens if I look between maybe 90 degrees and 180? So between 90 and 180 for each of these graphs. I notice here that sine is positive, cosine is negative, and tan is negative. So we see here that only sine is positive in the second quadrant. Same thing works for your third quadrant. Same thing works for your fourth quadrant. You'll note in the fourth quadrant, only cosine is positive while the rest are negative. Okay, so that's what all stations to central means. Yeah, and I've made that little note here. Just don't get confused if we're doing bearings, zeros up top. If we're talking about quadrants and all stations to central, zeros at east. Okay. Now, working with this, let's draw a couple of these angles so we get a bit of an idea. I'm just going to draw my nice little compass. And I'm hoping that you guys will see some sort of pattern here. So if I draw 30 degrees, all it means is I would draw this and I would label that as 30 degrees. That is part one there. Okay. If I was to draw 150, that means I'm going to go all the way. This would be 90. This would be 180. This would be 270. And this would be 360. Now looking at that, that there would be 150 degrees. Yeah. Or in other words, that little guy in there, because we know that 180 degrees makes up a whole straight line, that little there is 30 degrees. That's how we would draw 150 degrees, part two. Whoops. Part two, okay? Part three, now, if I'm talking about negatives, we've established that positives go this way. So it would make sense that if I'm talking about negative degrees, I'm heading the other direction. Okay, so if I'm going negative 150, that means I start at 0 and I move 150. So it's going to be somewhere around there, hopefully. And you'll note here, and I'll rub this out in a second, but if that's 150 degrees in the negative direction, then this little gap here is actually also 30. Are you picking up a pattern here? Okay, so again, part three is this guy. And then part four, we've got here 330 degrees. So I'm starting at 0, going 330 degrees until I hit back to there. That's 330 degrees. And take a look what happens in here. That becomes 30 degrees as well. So these are what we all call related angles. They're all related to each other, and they're all related to this acute angle, which is our first one. Okay. The last one here I've got is 390. It just means 360 plus an extra 30. So if I was to maybe do it in a different blue, you'll note here that this one here is actually your, whoops, just V, your fifth one. That is 390 degrees, yeah? Because it's 360 plus another 30. So I've gone one whole rotation. That's 360 plus another 30. I'll be heading in that direction, okay? Now, all of that is going to get to this. There's an idea here that there's general or related angles. Okay, so it's not always going to work, but if, let's say, for example, if I call this angle theta, it's going to relate again in the second quadrant, it's going to relate again in the third quadrant, and it's going to relate again in the fourth quadrant. Sorry about the dog. Puppy. So here we've got, that's also going to be theta. That's also going to be theta. And that's also going to be theta. The only difference is that now in this quadrant, this is going to be 180 minus theta. This angle here will be 180 plus theta. And this angle here is going to be 360 minus theta. Okay, so again, labeling everything, we know that's 0, 90, 180, 270. And I'm just putting in everything that we know here. We recognize that this is all stations to central. If you are good with this diagram, you should be fine for all the following questions. Okay, so if you haven't already, draw this down, highlight it, make it pretty, make it stand out, make sure you remember this, and make sure even more than that, you understand it. Okay, and you'll get better with it over time. Please ask questions if you need to. Now, example questions, they'll say, find the exact value of tan 150. Okay, now this is where it's a bit of a big jump. I've given you a lot of understanding, a lot of kind of notes. Now we're going to actually apply it to a question. Okay, so the first thing I'm going to do is I'm going to draw this. Okay, so 150, tan 150 is actually going to be down this way because that's 150 degrees, correct? Now, what I want to figure out here is this is actually 30. And so it's very similar. It's going to relate to it's going to equal the same thing as if it was tan 30. Okay. But where I also have to check here is, what do I know about all stations to central? What do I know about tan in the second quadrant? Is it positive or negative? Okay, hopefully you said tan is negative in the second quadrant. So here, what I've noted here is this should be the same thing. Tan 150 is actually the same thing as negative tan 30 because they relate to each other. They're the same thing. Okay, if you're unsure, put it in your calculator and watch. Tan 150 is going to give you the exact same thing as negative tan 30. Now, in the question, we're asking for the exact value. So now I do know what tan 30 is because I know that there's this triangle and I know 30 is this one. Tan would be opposite over adjacent. So it's going to be opposite over adjacent. This would be 1 on root 3. So in other words, tan 150 equal to negative 1 on root 3. That there's going to be your answer. Okay, let's try another one. Cos 210. Okay, and I'm just looking here. I may need some extra room. So look at me go. Changing things up as we go. Okay, again, I'm going to start by drawing a little kind of thing, figuring out where it is. Minus 210 means I'm going minus 90. I'm heading towards the left. Minus 90, minus 180, minus 210. So that will be minus 210 degrees there. But what I'll note here is the related angle, which is the guy in the middle here, that'll be 30 degrees, right? Because it's 180 here and it'll be 210 there. So it makes sense that that's going to be 30 degrees. And so the related angle here is also going to be 30 degrees. Now, what do I know about cosine in the second quadrant? I know it's going to be negative. So doing my working out, I can write cos of negative 210 is the same as negative cos, and the related angle, the acute angle, is 30. So it's going to be negative cos 30. And in the same way, I'm going to use my triangle just before. Cos 30 is adjacent over hypotenuse. So it's going to be negative root 3 on 2. And if you want to double check it, you should get the same thing. Whether you put in cos negative 210 or negative cos 30, you will get negative root 3 on 2. Okay. Sine 570. Bear with me, guys. You're doing good. Doing great. Some concepts are heavier than others. This is one of them. If you're watching and you're in my class, you'll have 2 lessons to do this, so don't freak out. Sine 570. So again, let's figure it out. I'm going to draw this. Now, 1 full rotation, that's 360, plus another, what's 570 take away 360? And then I need to do an extra 210. So that's going to be 90. That's going to be 180. And then so technically I go all the way around twice, leaving that little 570 / 210. Okay, because I've kind of gone around 570 degrees. Now, if that there is 210, it looks like our favorite number for today is actually 30. So that little guy there is going to be 30 degrees. And I need to relate it to my acute angle. So in other words, I'm going to look for when it equals to 30 there. Okay, now let's take a note. Right now, we're in the third quadrant. And so what do we note about here? Sine is negative because only tan is positive in the third quadrant. So in other words, sine 570, all right, this whole thing is the same thing as sine 210, which is the same thing as negative sine 30, because that's our related angle to our first quadrant. Okay. And again, using that 30 sine would be opposite over hypotenuse. It should just be negative 1 on 2 as your exact value. Whew. All right, last one. Sec means all it is it's 1 on cos. So in other words, think of it as 1 over cos 120. Okay. And let's figure this out. So let's figure out cos 120 first. And then we'll try to figure out, what do you call it? We'll work with cos and then we'll figure out what sec is. So if I'm looking at cos 120, what I'm going to draw there is it's going to be 120 is going to be roughly there. And what you'll note here is now it's not actually 30, it's not 60, it's not 30 degrees, it's now 60 degrees. So that means the related angle to the acute, that would be 60 degrees there as well. Okay, it's the same. Okay, now I'm also noting that it is in the second quadrant. So if I look at all stations to central, I'm in the second quadrant, that's 120, but I know that cos is negative in the second quadrant. So all of this is to say that cos 120 is the same thing as negative cos in your related acute angle would be 60. So again, I'm going to find whatever cos 60 is, and I'm going to use my triangle here, a over h. So it should be 1 over 2, and it will be negative 1 on 2. Okay, now we're almost done, but here we're not looking for cos, we're actually looking for sec. So if I take sec of 120, I know it's going to be the reciprocal. So in other words, instead of saying negative 1 on 2, it'll just be negative 2 on 1. There's your answer. Okay. I know it was a little bit confusing. We'll go through more examples at school. If you're just looking at this online, maybe watch it a couple times. Maybe watch someone else do it. I don't know. Good luck. Figure it out. Love you guys and see you all later. Bye.